Assalamualaikum and a very good morning to my fellow lecturers, Dr. Zalila, Dr. Ikhwan and Dr. Siti Fatimah. Hopefully you are all in a good health and safe wherever you are. Today, I would like to present my proposal entitled with Functionalized Biochar as a renewable adsorbent for efficient grease removal by me, Khairul Ajwad bin Shamlan, matrix number AW180092, supervised by Dr. Siti Fatimah Zahra binti Muhammad Uzi. First of all, we will start with background of study. Food preparation, cleaning activities as well as industrial activities has contributed to release of environmental pollutant. For example, in the production of vegetable oil, the effluent released from refinery process generates complex composition containing mineral ions, dispersed oil, grease, organic products, heavy metals and others. Therefore, the emergence of biochar as more efficient adsorbent than activated carbon commonly used in industry is applied for removal of oil and grease from effluent. Problem statement. The problem starts with the release of effluent. Effluent or wastewater release contains organic and inorganic material. According to Santos, effluent released from production of oil generates effluent containing contaminants as listed as in the slide. Wastewater generated from food preparation cleaning activities also generate high concentration of fat, oil and grease wastes. A little bit data about fat, oil and grease. In Malaysia, major contribution to sewer blockage is from fat, oil and grease buildup. In Sydney, average total suspended solid and oil and grease released from restaurant are 3024 mg per liter and 3630 mg per liter respectively. And lastly, US Environmental Protection Agency has identified fats, oil and grease as pollutant of concern. Therefore, the significance of study. Abundance of biomass produced as byproduct from various industries can be converted to biochar. For example, the production of palm oil has generated byproduct such as palm kernel and palm shell. These byproduct can be converted into value-added product such as biochar. And this value-added product can be used for various other applications. Biochar is used to replace activated carbon because activated carbon is not cost effective and environmental friendly. Therefore, biochar as a low cost material and absorb effectively compared to activated carbon is used. Research objective. The objective is to synthesize nanomanganese dioxide biochar using manganese sulfide and potassium permanganate. Secondly, it is to analyze biochar adsorbent capacity in absorption of oil and grease. Scope of study. The biomass that will be used for biochar production is from rice husk, and to represent the effluent from production of oil, we will use crude palm oil mixed with sodium chloride and ACl. Biochar will be modified by functionalizing rice husk biochar with manganese sulfide and potassium permanganate to produce nanomanganese dioxide biochar. And this nanomanganese dioxide biochar will be characterized using SEM and FTIR to obtain its morphology. Lastly, the concentration of oil and grease will be obtained by using oil and grease analyzer to measure the adsorption capacity. Next, we will go to the next part of our presentation, which is literature review. Firstly, the general view of oil and grease. Oil and grease is a group of organic element that has characteristic of low affinity to water. It has complex chemical constituent as waxes, fatty acids, hydrocarbons, soaps and lipids. These chemical constituents can be classified as oil and grease substances. Refinery of vegetable oil using chemical methods will generate a high volume of wastewater containing high concentration of oil and grease, which is very hazardous to environment. The table stated the number of fat, oil and grease released from several industries, which is seafood processing, meat processing wastewater, restaurant wastewater and typical municipal wastewater. The adsorption process is a process that occurs due to attraction of solute towards surface of substances. The process is managed by specific interaction, such as van der Waals interaction and hydrogen bond. The adsorption can be classified into two types: physical adsorption and chemical adsorption. Physical adsorption involves intermolecular attraction, while chemical adsorption involves exchange of electrons, which is forming ionic bonding between adsorbent and substances. Application of adsorption has been used for wastewater treatment by removing heavy metals, nitrogen and phosphorus, making water available for drinking. Next, it is used for controlling global warming by removing gas emission of industries such as carbon dioxide, methane and nitrogen oxide. Next, we will go to biochar. Biochar is a carbon-rich product obtained by thermal treatment in a closed container with low or non-existence of oxygen. It contains high amount of carbon and also minor portion of inorganic component. Biochar has surface area that contains functional group that gives beneficial properties to conduct adsorption process. These functional groups will form interaction or ionic bonding between adsorbent and the substances adsorbed. Porosity of biochar is the main properties of the biochar. Porosity is the amount of total pore volume relative to the total bulk biochar volume. The adsorbate will be absorbed into the porosity of the pore of biochar. The figure on the left side of the slide is the figure of biochar in a closed view. You can see that biochar has carbonized phase and non-carbonized phase, and also surface functional groups on the surface of biochar. Next, we will go to biochar activation. In this study, we use calcium hydroxide for activation. NaOH can increase surface area and porosity. According to Wang and Kaskel in 2012, alkaline-based activation use lower activation temperature and produce high yield and well-defined micropore structure. According to Ahmed in 2016, alkali modified biochar possess high adsorption capacity of furfural due to basic characteristic. Therefore, we use calcium hydroxide for activation of biochar. The figure below is the mechanism of adsorption in the biochar, which can be divided into 3 steps. Next, we will go to active group of support material. The biochar can maximize its ability by modifying it using chemical reagent or cross-linking. Cross-linking is formation of chemical links between surface and adsorbate by promoting additional functional groups on the surface of biochar. Therefore, we use nano metal oxide so that it able to produce larger specific surface area, cation exchange capacity and porosity compared to crude biochar properties. Cukup. Next, we will go through methodology of my study. We will start with the collection of sample, which is biochar, manganese sulfate and crude palm oil will be purchased from outside, and potassium permanganate will be obtained from laboratory. Next, we will go to activation of biochar. Biochar will be activated using 1 molar NaOH calcium hydroxide solution. Next, we will go to biochar functionalization, but modification solution of nanomanganese dioxide will be prepared by mixing together manganese sulfate and potassium permanganate. Nanomanganese dioxide modified biochar characterization will be conducted by using scanning electron microscopic SEM analysis and Fourier transform infrared FTIR analysis. Lastly, we will obtain the measurement of concentration of oil and grease by using oil and grease analyzer infracal to measure the concentration of oil and grease absorbed by the biochar. Expected result. The biochar complex in the absorption of grease can be evaluated since we have the exact number and the exact measurement. Secondly, we will help to identify factors that can be improved in the future to increase the effectiveness of biochar for adsorption application. Lastly, proposition of biochar will give alternative methods to industry to apply biochar for their treatment application. And that's all from me. Thank you.